Okay, hello everybody. Welcome back, and I hope that you enjoyed your coffee break. Right now, we're having up next Maksim Kariagin. He's a data science lead at Medius. He's going to show us how AI is being used in the music industry for uplift modeling and stream forecasting, helping labels predict what listeners want and optimize promotions accordingly. Please, guys, pay very close attention to this session because it's going to be full of a lot of amazing information. The stage is yours, Maxime. You can go ahead and start your session.
Okay, yeah, thanks for having me. Thanks, guys, for joining my session. So I guess I can't add anything to what Yusuf said. So just maybe one ask to you guys, everyone who join us, just don't put off the end of the session your questions. So if you have some ideas or questions, please interrupt me. Please drop the message in the chat. So from time to time, I will switch between a presentation and a chat. Yeah, I'll see all your questions. Yeah, let's start. So everything is correct. So my name is Max. Currently, I'm data science lead at Metis. Metis, it's a consulting company in Amsterdam. So I'm responsible for lead data science department. So we help companies across different industries to help and apply AI and analytics to make better decisions. So, but today I'm going to share the lessons and the real world AI applications, which I've learned when I was in a Warner Music Group, where I served as a director of research and analysis. So, and in this session, we will walk through two of the most impactful AI applications we worked on, and which pretty still up to date nowadays. It's Uplift modeling, which help us improve the precision of promotional marketing campaigns, and stream forecasting to better time our investments and spot rising trends. So I guess all of that problem could be familiar for you, but we'll figure out with that. So, but let's begin by walking through the structure of our session. So the first we'll define what issues music business is faced with, but at the same time, of course, keep in mind that all the problems which we will discuss today, so it's not only up to date for music business, so it's also up to date for many businesses. So when we'll dive into the data, so what types of data the industry and the music generates, and what kind of data we working with, and what potential it holds, potential, I mean, from the side of AI implementation. So, and after that, we'll look at two levels where AI can be applied. And the second part of the talk will focus on two core applications, so which we already mentioned. So the first one, it's uplift modeling, and the second one, it's stream forecasting. In Warner, in terms of stream forecasting, of course, we wanted to address the problem not only forecasting and streams or sales, but it's also about marketing optimization. So before all that, let's line on one thing. What does the music business actually looks like, and what it is? So basically, it all starts with A&R. It's artist repertoire department. So this department responsible for recruiting and scouting, discovering new talent, like future stars. So then we move into recording and production. So the recording and production, it's more about music production. It's creating songs, refining them in the studio. When we already got a product, when we already produce the music, so we need to promote it somehow and launch a marketing campaign, building awareness among our fans. And after that, we move into releasing and distribution. So getting the music onto streaming platforms like Spotify, Apple. So basically what we use in our daily life. And it's a part of distribution. So, and then finally, everything goes well. So we reach monetization and the royalties. So it's this part only about money. So this is where the revenue is collected from streams, ads, live concerts, and all activities which our artists perform. So, and each of these steps generates data, and each step involves decisions that can be benefit from AI. So, but at the same time, so now we know in the structure how it works, but how ready is the industry to actually apply AI at each of those stages? So, well, that leads us straight to the first big problems, which basically, I suppose, not only music business faced with. So the problem actually sounds pretty simple, but it's not about techniques. So it's more about concept. And the problem sounds like AI is everywhere. So we've heard about AI in public everywhere, every conference, every news, every topic, and many businesses, of course, care about. And I've heard a lot of times from not only executives but from IT department, that science department, that we'd like to use AI too, but we are not quite sure how we need to apply that and where we need to apply that. That's completely fair. So what ends up happening, what kind of problem could be like the next step of that? So it ends up that running exploratory pilots that never scale. So we could launch a lot of pilots and try to implement and apply AI, but never scale that. And the second one, we faced and pretty often time get stuck waiting for the perfect use case before they start. And this uncertainty is one of the biggest challenge, not only for music, but for many businesses. It's just a barrier for adoption. And but once that's been figured out, so for example, we figure out how to apply and where to apply analytics, machine learning, and AI as well. But once that's been figured out, teams quickly run into the second challenge. They have way too much data, and nowadays, I guess it's also up to date because we have a lot of providers. We have a lot of open data. We have a artificial data which we could generate by Gen AI, by GPT. But what we need to do with this data, and we don't have a clear idea where to start from that. So in the music business, we are not talking about millions and billions, but we're talking about trillions of data. And at Warner, we were processing around 10 billion records every day. So to be more simple, I guess we could consider one record, it's like one stream from one device, from one user, from more than 180 different companies. It's called the DSP, a digital service provider, like a Spotify, Apple Music, Amazon, TikTok, YouTube, or even Instagram. So we had over 15,000 parameters. It's a feature, and at the same time, it's a variable. Everything from play counts to skips, some likes, some engagement activities, to geodata, device types, gender, or playlist positions, and more. So having data, of course, it's pretty great, but without structure and without understanding of purpose of clear purpose, I would add. Of course, it's just a noise. So let's take a closer look maybe at what kind of data, not only numbers, but what kind of specific data and the source of data we have in the music industry. Yeah, so let's break this down. So our core, it's data, as I mentioned, from DSP, which represent by Apple, Spotify, and different streaming platform. So they give us event level data. It's every play, every skip, every like, and every save to library. And it's also enriched with metadata like device or location, or of course a timestamp. So we also leveraged third-party tools like a Chartmetric. So it's just a third-party provider which aggregates social and platforms data. So it's more about ranking, follower growth. So it's kind of more social representation data in numbers of the artists. We also have a Sadaton. So Sadaton began like a startup, but 2018 Warner acquired Sadaton. Sadaton is just a one more tool we used. It's more about artist performance with the social metrics and the engagement signals, which pretty helpful and useful for A&R department who care about to find a new star and scouting new artists. And then we had our audio layer. So it's among all these that source, it's one of the most technical provider. It's open source. It's Librosa. It's Python library that extracts technical features directly from music. So it's features like tempo, share of noise, or like a sentiment of music, or of course a type of music and genre of music, but also technical part of signal like spectral energy or harmonic richness. So and all this combination gave us behavioral data, social signals, and track level audio fingerprints, and just a feature. So the next question becomes actually logical. The next step, what kind of problems and what kind of tasks we could address, we can solve with all of this data. So AI in music represented, and actually is meaning we could organize all these cases into two buckets. So the first one, it's operational layer, and the second one, it's a strategic layer. And let's start on the left, maybe. So operational layer, it's more about use cases which focus on day-to-day marketing, and not only marketing, but day-to-day routine execution, like A/B testing or customer acquisition cost. And these are more short-term, often campaign-based tasks where turnaround time matters. On the other side, it's a strategy layer. It's more about strategic use cases. These are more about long-term planning. But at the same time, some of these use cases are extremely hard to execute in the music, and actually answer is pretty simple. So we have, for example, in terms of like a consumption of products, consumption of content, we have a one user who listen to music on Spotify, on Apple, watch the videos in the TikTok and the YouTube. And be honest, it's just multiple platforms. So moreover, it's totally different platforms. And each of these platforms is a separate company with separate data systems, and none of them are linked by a common ID. So we can't build like a customer journey map and mapping all data by one ID from different platforms. So this is the biggest structural challenge in music, not only analytics, but in the music business for today. And many companies care about it, but nobody can address it so far. And we found that instead of chasing a unified customer view across all platforms, it was more realistic and effective to organize our efforts around the listener behavior over the time. And so everything what you see here, it revolves around one individual listener and how their relationship with an artist or a track evolves. So, and of course, I repeat that it works and it's pretty up to date, not only for music business, it works for other business as well, of course. So it all starts with the acquisition, discovery and onboarding flows, and the first impression where we need to attract our listener to our business. And then comes development. So development is more about engagement growth, how fans explore related contents. So, for example, development also pretty popular in other business. So, for example, I worked in a telecom. In the telecom, it's maybe not called development, but it's called a cross-sale, upsell techniques and idea or marketing campaigns, but it's everything about development. If they stay active, our user, so we enter the retention phase where we try to keep them streaming regularly. Yeah, because we always for this all customer lifecycle, we care about like a screen time. Of course, it's not a screen time; it's like a listener time. But anyway, we care about retention. And if they stop listening altogether, we move to reactivation, identifying who's worth reaching out to, and how. So each of these stages unlock different types of modeling opportunities. So as we mentioned, for example, for acquisition, it will be like onboarding or trigger communications, or maybe we'll try to predict and launch some response model. For development, it will be like a scoring model for propensity for upsell or cross-sell, which led us to increase the lifetime value of our customer. And for retention, we relied heavily on churn prediction, LTV estimation, and tailored some retention offers and more fit marketing campaigns. And all of this sits on top of two major engines. In Warner, it was two main pillars. So one of them, it's Uplift modeling to decide who we need to target. And the second one, it's sales forecasting to understand when and where we need to care about our value and where value will be created. Two of those models became top priorities. And of course, when we talk about sales forecasting, I guess it's also pretty really non-unusual for all businesses. But today we will try to look into sales forecasting, not in terms of sales prediction, but how to manage marketing campaigns, how to reduce the costs, marketing costs, via help of stream forecasting. And then bring us to our first actual practical challenge. So how do we retain our listeners and more effectively using AI? Because no matter how strong our acquisition is, because when people stop not only listening our music, but maybe stop buying or making purchases, the business loses momentum fast. So, and let's talk about our goal. So our prime goal was we just wanted to increase the number of streams and reduce the churn. So it's pretty seems simple, right? But traditionally, we and I approached this in 2 steps. So the first one is just a churn prediction, right? So it's just a simple in terms of understanding binary model. Of course, it could be not simple in terms of algorithms, but anyway. So the first step is just to understand who's likely to stop listening, who's at risk, who's affin to churn. So the step number 2, it's launch a retention campaign to re-engage those users. And but here is the problem that, of course, we understand the churn probability, but what do we need? What we are going to do with that? So it's just a number, right? It's just a probability, and after that, of course, it's not enough to organize. Not only our business, it's not enough to organize our retention strategy, because the retention strategy supposed to communication with the users, with the clients. And in that case, we need to make a step one more for communication with the customer, because of course, not every user should be contacted. As a result, we have 4 types of customers we identified through modeling, and at the same time, which churn prediction and like a marketing campaign response prediction don't cover. So the first one type of customer, it's sure things, like they'll stream no matter what. So contacting them just wastes our money. So if we launch a campaign for customer, if we even predict which customer we need to contact, we also will find second type of customer. It's persuadables. These customers are our golden group, and they will only stream, they will only buy, they will only use our service or like a product of our business if we engage with them. And this is our target audience, basically. But at the same time, we also have 2 types additionally of customers. So the third one, it's lost causes. So they will not buy, they won't stream, even if we try. So it's again a waste of money. And moreover, so campaigns will not work here. The last one, it's do not disturbs group. The risky group, because contacting them could actually make things worse. And that kind of people who not only care, but they just started to nervous when we wanted to communicate with them, and they attract all our communication like a spam. And moreover, they could become not promoters, but detractors of our business. And what we want to do is focus only on persuadables. And this is exactly where Uplift modeling comes in. And what we want to do is focus on a new kind of model. So we spoke about churn prediction. We spoke about launch campaign. It's meaning like a campaign launching and prediction response for a marketing campaign. But we need a new kind of model, not one that predicts behavior. It doesn't matter churn or like response for campaign, but one that predicts the change in behavior caused by intervention. And this is exactly where Uplift modeling comes in. So, and yeah, now let's maybe not take a break, but just I just wanted to know, just maybe make a quick check-in with everyone. Just a simple question. So has anyone heard of this, Uplift, or maybe just heard about the concept? And please feel free to drop a message in the chat. And if you've used any specific types of Uplift models, yeah, I'd love to hear which ones. Okay, Islam. It will be the first time for Islam in terms of Uplift model. Yeah, but maybe someone already heard about it or also familiar with that for the first time. Okay, so if you have some idea before we start to deeply dive into Uplift modeling, yeah, please feel free to type into the chat maybe the concept which you work with. And so basically Uplift is just a difference in outcome caused by an intervention. So that's it. So for example, how much more likely someone, I mean by our user, our customer, is to stream a track because they received a campaign, or buy a product because they received a marketing campaign, compared to if they had not, if they did not get a marketing campaign. So in our problem and our task in Uplift modeling is just to evaluate of value of communication. So let's start with the most intuitive and probably one of the most widely used approach in Uplift modeling. So it's two models approach. So the idea here is simple. You just need to train two separate models. So one of the for the treatment group, so people who saw the campaign, and one for the control group, people who did not. So we use a W, so to indicate whether the user received the treatment. So of course it's a binary, not a target, but a binary variable. So 1 means yes, 0 means that we did not communicate with a user. So what do we do? So the first, we collect data for both groups and their behavior and engagement. So totally we have two groups. So then we train models to predict the probability of engagement with the treatment, and another model without treatment. And then for the day, we will have two models. And finally, the difference between those values is our Uplift score, the estimated impact of the campaign on that specific user. So there are two main reasons people use this method. So it's just easy to implement, right? Because we need to build just two models with actually same target. Will our customer, will our client communicate with us? And the first model with a marketing campaign, and the second model without marketing campaign. And we need to calculate the difference between these two models. That's it. So, and it works also with almost any standard ML model, like XGBoost, neural nets, or logistic regression, whatever you want. But also it comes with a trade-off, because the errors from both models could compound. So we need to care about not only errors in each of them, all right, but in the end of the day, we need to care about compound error. So this model does not evaluate, does not predict the uplift directly. So while it's a good starting point for familiar with uplift modeling, but it's not always the most efficient or stable option if we talk about maybe scale decision. And that brings us to the class transformation approach. And this method is known as class transformation. And it all allows us to train a single model by redefining the target variable. So we will not care about two models, or first one for communication with the customers, second one for not where we did not communicate with the customer. We just care about, instead of that, we just care about one model. And instead of predicting whether someone will stream or not, we ask, was the campaign effective for this person? Yes or not? That's it. So to do that, we create a new target variable, let's call it Z, using this formula. So here, Y is whether the user streamed our target variable, yes or not, binary, and the W still indicates if the user received the treatment. And in that case, in the case of class transformation, we define a good outcome where Z equals 1 as a user who streams after receiving the campaign, or a user who does not stream and was not contacted, meaning we saved budget as well. That's also a good event for us. If we talk about bad events, you could see also below. So it's just two examples. So the first one, user streams without campaign, a missed opportunity for us, or the campaign was sent but did not help. So the user did not stream. So the uplift equals 2 times the probability that our z equals 1 given x. Just remind that x, it's about like a characteristics and variables about features about our user, and -1. It's more stable than the 2 models approach because we are only training 1 model, but at the same time, it's still not modeling uplift directly, and we're just transforming the labels and approximating it. And so both the 2 models and the cost transformation single model are really helpful. And if you need to save your time, and if you need to launch, if you have some restrictions for time to market, yeah, that would be the great decision. But neither actually models uplift directly. So if we want to do that, we need to have a bit complex method, but which was built from ground up for especially uplift prediction, and that's called just uplift modeling, uplift random forest. So Leo Gelman proposed that, I guess, around 10 years ago, and after that, then back, everyone started to care about uplift modeling more because before that, it was just like using logistic regression or a different model for addressing uplift modeling to build like 2 models and find the difference, and that was uplift. But since Leo Gelman proposed this approach, that would be like a new area of not AI. Then back, it was just a machine learning. Yeah, but it's one of the first algorithms designed specifically for uplift decision trees. So the idea is simple, but pretty powerful. So instead of splitting the data to improve overall prediction accuracy, we need just build a decision tree, like a standard decision tree. And this method chooses splits that maximize the difference in outcomes between a treatment and the control group. Because to addressing these problems, so we put in a decision tree all groups, and treatment and control groups. So we measure the divergence in response rates between these 2 groups, and we choose the split that increase that divergence the most. This is our uplift signal. So one of the metrics we use for divergence is a callback labeler divergence shown in a formula. And it's a way of comparing probability distributions. So how different is the response rate in the treatment group versus the control group? So on the right side, you can see an example implementation uplift random forest classifier in Python. Is just a sclift library. So it doesn't matter what we talk about uplift decision tree or uplift random forest, right? Because the random forest is just a set of many decision tree, and which you use the begging. And after Leo Gelman proposed the decision tree uplift modeling, after that short time, somebody already proposed a random forest classifier for uplift. And you just define your control group, fit the model on the features as just a usual model, and set the, as you can see in model fit, we have not only X, Y, we have also treatment column, and it gives you uplift predictions per each user. So this approach, one of the best nowadays, which use directly models uplift and works well on larger data sets. Yeah, because the random forest, and we could also translate this in a boosting way. And we know that begging, especially if we talk about random forest, it works really well with a larger data set. And it gives interpretable outputs, so we could visualize the trees at the segments. So and actually, let's try to make it because we talk about a bit overwhelmed stuff and formulas. So let's take a look how it works in a real example. So on the left side, so we have a decision tree where we put a treatment group, where I put a control group. So we have a green circle. So the green bubble means that our communication in the case of treatment, or our not communication in the case of control. It means that we have one as a target, right? So we have a good response from the user. That means so the gray one means that we didn't get a response from our user. So let's break this down visually. So what you see here is how an uplift tree split is calculated using Kalbach labeler divergence. So I put also on the right side, upper side, to not forget the formula of Kalbach labeler divergence. And at the top is our parent node before any split. And we'll look at the response rate in the treatment group. So that's 4 out of 6. So our P equal 0.6. And as a control group, it's 2 out of 5. All right, so the Q will equal 0.4. So we plug those into the KL divergence formula and get a baseline divergence score of parent node, which will equal 0.145. And then we have to evaluate the potential split. And actually we'll do the same for left node and for right node. So for left branch, the divergence here is pretty strong. And so more divergence, it means more more distance between a treatment and control, right? So that's better. So on the right side, we have already lower divergence. As a result, we've got a 0.05. And next, we weight those divergence by the number of samples in each branch, because it was not equal. And that gives us a total weighted divergence after the split of 0.6. And finally, we subtract the before-after values, and that's how we calculate the gain, right? Our gain equal 0.4. So what does it mean? So this is the gain. Actually, this is the improvement in the treatment versus control separation. And it's a difference. So before split and after split, right? Of course, when we launch different algorithms, when we launch, especially now, tree, for uplift, of course, we want to find the best splitting. Yeah, so the delta, the gain, will be better when we have the gain more, just bigger. And the tree will choose the split if it results in the highest gain, right? So this method optimizes directly for uplift, not just for accuracy. And we need to just care about it. But at the same time, we could build a lot of overfitting decision tree, combine that in random forest, and get a good result. So, but just maybe one tip: just be careful when we use categorical variable, yeah, because decision tree has a intense like a overfitting pattern, and random forest, and especially also decision tree, and also XGBoost, they care about more, and they bring more importance for a variable which has a lot of category, right? But we just simply could address this problem using mean target encoding, and that's it. So, and actually, this was one of the our best use cases which we implement in Warner. So optimizing advertising spend for a new release campaign. So we just launched a pilot project. We had a marketing campaign planned across platforms, TikTok and Spotify. And these platforms provide us to communicate with the customer directly. And we launched two types of segmentation. So the first one was a traditional agency-based segmentation. So we just got answers from agency which we working with, and also our own AI-driven segmentation. We used our Uplift models to identify persuadables customers and the people most likely to engage only if they see the campaign. And with the AI-based Uplift model, the cost per add to library, one of our KPI, was 30% lower than with Uplift models from agency, right? So it's not a Uplift models, but at the same time, they try to build it manually. But like a true AI Uplift model, which we used in Warner, so it showed 30% cost of adding train to library lower. So it showed that Uplift model is not just a fancy algorithms, but at the same time, it's a business tool that saves money immediately. So let's take a look how we used also forecasting, not only for streams, but for demand itself. So this is where stream forecasting comes in, and it's one of the, of course, everyone knows that's one of the most, and I guess only one decision when we want to forecast sales, and powerful tool for not only marketing, but for finance, for planning, for campaign timing. So our goal was to develop a model that could forecast 3 months ahead, which will forecast the sales in terms of Warner, in terms of music business, it's streams, for any track that had at least 1 week of listening data available. So we used a rich set of signals to make the model as a context aware as possible. So we put a historical and liked stream counts. So we put a ratio and moving average, which we extract from just a time series. We also put a lot of track metadata and Librosa technical features. And in total, we had about 1,700 all features and parameters. So compared to baseline models, our best setup improved forecasting accuracy by 60%. And let's talk about what is the setup and what is the inside. So under the hood, we used an advanced setup built on Facebook Propet, and but with some important modifications to make it work for our case, for our music streaming problem. And actually, this is not exactly Facebook Propet. So this is a wrapper class, Facebook Propet, built around Facebook Propet library. So, and actually there are 4 key components here. So the first one, it's custom regressors. So this is where the magic actually happens. Of course, it's an obvious step. But at the same time, when we talk about ARIMA, like a simple model, right? So we only like a model time series and forecast sales based on our previous activity, right? So without any regressors. But here, of course, we injected our domain knowledge directly into the model by adding customer regressors. So such like audio features from Librosa metadata, like a genre, artist, tire, or track release date. And also we put there marketing costs. So we'll back to that in several minutes. And the second one, one of the important components of that, it's MC sampling. It's a Markov chain. To go beyond point estimates, we use a Markov chain sampling to generate a probabilistic forecast with a credible intervals. So in the end of the day, so using ARIMA or using XGBoost for forecasting, we could get only like one number of our like a target, right? Potential target. But here using Markov chain sampling, why it's called sampling, because every time we, based on different sample, we predict like a diapason, a range of value, our potential value. And of course, this, it's not only sounds like, but in real life, it's like a hedge. And it's decreased the risk because we did not predict the specific value, we predict a range. So we also use a dynamic seasonality and thread modeling. So we modeled daily, weekly, and holiday-based seasonality, as well as long-term trend decay. And the last but not least, we use a change point detection. So we use it's to let us to automatically identify when a track trajectory changed. For example, when we use a campaign, when it was a playlist inclusion, and we did not need to put it like a regressor, right? So the change point detection already try to provide it. Even if we're faced with a social media virality. So in combination, these adjustments gave us a flexible and robust forecasting engine. And but building accurate models is only part of this story. And music, not only in the music, and many businesses where stakeholders come from marketing, from like a not technical department, it's just as important to be able to explain how the model works. And of course, regressors and MCMC sampling or change point detection will sound like a bit overwhelmed. So, and that brings us to the next key topic, interpretability. And here I have to make maybe the second check-in of today's session to ask you what methods do you know for interpreting complex model, and please drop them in the chat if you have idea. Or maybe what the most popular interpretability techniques which you are using in your daily life. Oh, great. Yeah, Ahmed shared that he using shop values. Yeah, shop values is pretty not only interesting and pretty colorful for business, but at the same time it works when we need to interpret each of parameters. And yeah, for example, for uplift modeling, Ahmed also shared feature importance. Yeah, that's really nice key points and a selling point for business when we want to interpret decision tree. Okay, but actually in our case, and here is actually I just collected several interpreting approach what I know, and but we are running ads right on Instagram and YouTube, and but streams could come not only from Instagram and from YouTube. So you launch ad on Instagram, but you could get streams from Spotify or Apple, and there is no clear actually not only user level link. It's not clear how the our marketing costs in Instagram increased on our streams, because it's happened not on the same platform. So we can't run traditional attribution models, and we can't run like effective calculation for each platforms, right? So for example, return on investment calculation for YouTube, or ROI calculation for TikTok. Instead, what we can do is just add the marketing spend as a regressor to our forecasting model, and then interpret the impact of that variable on predicted revenue. In our case, it's a streams, but at the same time, it's a revenue. It's just synonymous. And that's actually provided us a proxy for media effectiveness. And that's why we use a partial dependence. So the partial dependence plot is just a plot which showed us how our predicted number of streams or sales forecasting, depending on how much we spend on marketing. So on the x-axis, you see marketing spend. On y-axis, you could see not sales, but streams. It's pretty similar based on the model. And already here, and of course, we can't get this from the shop value or variable importance. Only partial dependence plot could provide that. And what we see in here plateau effects and zones where increasing marketing spend no longer leads to more streams. And even if we double the budget, we could see that sometimes it will not bring us to double streams, right? So the number of predicted streams barely moves. And this insight is incredibly valuable for planning, and not only for planning, but for our marketing team and for our business, and also for us as well, because it tells us not just how much we can spend, it tells us not how much the streams and the sales we expect to get for the next 3 months. It showed us how much we should not spend for each specific track. And by applying what we saw in the partial dependence plot and avoiding overspending in plateau zones, and we were able to save 27% of the marketing budget without sacrificing stream performance. So we just less spending and getting the same streams. And this is where forecasting and the interpretability give us real business impact. And and we come to last slide. And but here's two quotes, and one of them from Stephen Hawking, and which remind us that AI can be the best or the worst thing to happen to humanity. But of course, it's up to us to decide how we build and apply and govern it. It depends on how we'll apply that. And one of them from Max Lusada, it's CEO of Foreign Music Group. So, but at the end of the day, so whether you work in the music or other business or retail or production or energy, but in a machine learning, I hope this session showed how AI can be applied and how AI can be a powerful tool when applied with just two things. The first one is just we need to have a clear purpose always, right? And the second one, of course, the data. Yeah, if we have a purpose, if we have data, I guess implementation of AI is just a question of time. And if you want to connect or chat more, so feel free to scan the QR code. And I'm always happy to share ideas. Yeah, please add me in your LinkedIn. Yeah, and now I guess we'll have time for a Q&A session. Yeah, and if you have any questions or ideas, please feel free drop in the chat your message. Yeah, and we will talk about it. So maybe you have some several or similar, not only ideas, but projects in your own business. Yeah, of course, I understand that the music business is pretty niche. Yeah, but maybe you shared your ideas, how it works in your business. So if no one have questions, yeah, I just have to say thank you. Thanks for being here today with me. Yeah, thanks for having me. Yeah. So see you next time. Yeah. Yeah, thank you guys. See you. Oh, you see, yeah, just
Yeah,
just didn't hear you. Yeah, you see.
Yes. Okay, perfect. So I'm pretty sure everything is good. None of the audiences have any questions so far. So yeah, I believe that's everything. Thank you so much, Maxim. We really
Okay.
appreciate you being with us today, and thank you for delivering such a very fruitful session today. And I really hope that that people just enjoyed the session. And
Thank you. Thank you.
that's gonna be everything for this session. There's gonna be one more session just before we end today. So please, guys, just hold on, and we're just gonna see you once again after the break. For the meantime, you just enjoy your break until we meet again. And thank you once again, Maxime.
Yusuf, yeah, thank you. Thanks for your warm welcome.
I hope you will be
If
having
you guys
a wonderful
will
rest of your
get
day.
questions, yeah, please feel free, find me in LinkedIn and ask about it. Yeah, see you. See you.
Yeah, actually, if you want, you can share your contact streams like LinkedIn or something. So in case someone needed to reach out to you, they can
Okay,
send
okay,
you a message
yeah.
or something.
Thanks, Yusuf.
Sure. If you want, you can share
No,
your
I've
screen or send
already
it in
shared
the
my
chat
screen with the
so
QR
they
code.
can
Yeah,
connect.
and also I guess all attendees could find a LinkedIn link on the DSC MENA just website. Yeah, just put it on my LinkedIn. Yeah.
Exactly. Yes. Yes. Sure. Okay. So you can find it in the DSC MENA page on LinkedIn, or
Okay.
you can
Yeah.
go to our
And
website.
Yusuf, I also find questions from
Actually, I can
Rabab.
say
So he asked about the presentation,
yes.
but I guess it will be possible, right? So I guess your conference will provide the materials with the attendees, right?
If you want, if you have it uploaded on a Google Drive link or something, you can send the link right now in the chat. Or if you don't have it right now, you
Okay.
can just send it to us, and
Okay.
then we'll
Okay.
deliver
Yeah,
it
we'll
to the
figure
attendees.
out it. Yeah. Thank you. Thank you, Yusuf. See you.
Welcome.
See you. Bye bye.
Thank you, Maxime.
Have a good day.
You have a good day. You too. Goodbye.